Hi guys, I've come up with a creative way to add some mobility to your big heavy shop tools that does it without sacrificing stability, and it won't break the bank. I'm going to show you how to build one for your shop. My drill press happily lives in the corner of my shop, taking up just a few square feet of space. 95% of the time, that small spot meets my needs. But once in a while, I need to pull it out away from the walls to handle a long piece of stock. And pulling it out is a challenge. It weighs over 100 pounds and is relatively top heavy. It doesn't slide easily, and it can gouge the top of my workbench doing so. I got the idea for a solution when I was recently setting some doors. I started using one of those air bladders that can easily lift several hundred pounds. Add that idea to some unconventional casters and a few hinges, and the result is a mobile base that makes moving the drill press around a breeze. I built this to fit my Rikon drill press. By the way, I have a full review of the drill press on my channel. I'll include a link at the end of this video if you're interested. Anyway, the concept for this mobile base could easily be resized for virtually any shop tool. That said, it would take some more thinking to handle something substantially heavier, but the design works great for this 100-pound tool. Let's start with the supplies that you'll need for this build. For the hardware, you'll need some hinges. I used a piano hinge that I got at the home center and cut it to size. Next is the bladder, or sometimes called an air shim. These have come down significantly in cost, and there are lots of sizes to choose from. I got a 2-pack of them from Amazon for under 15 bucks. I used some 5/8 inch ball bearing casters for the feet. These are typically used for material handling, like a lumber stand, and they are used face up. When you turn them upside down, they lose a lot of their weight support rating. For that reason, I'm using 10 of them for this application. I got these from Harbor Freight for $1 a piece, but you can also get them from Amazon too. The rest of the stuff is basic hardware you can get at most hardware stores. You'll need a set of 4 small springs about 1 inch long and some 5/16 by 2.5 inch carriage bolts. The springs should be able to fit around the bolts, as you'll see when we start the assembly. Lastly, a set of 4 clevis pins. I found these in a box that were labeled trailer hitch pins, and they worked fine. I start the build by measuring the base of the drill press and cutting out 2 oversized pieces of 3/4 inch plywood to act as the base. I then lay out for 4 holes, 1 in each of the corners. This is where the carriage bolts will come through, securing the top to the bottom of the base. I first drill a countersunk hole the depth of the carriage bolt head with a Forstner bit. Then run a 5/16 inch through hole. These need to be straight and line up perfectly top to bottom. The drill press works well here. After the holes are drilled, seat the carriage bolts into the wood by tightening them down and make sure the heads are below the surface of the wood base. Afterwards, pull the bolts out and separate the 2 pieces and set the top aside. Mark the center of the bottom board of the base. This is roughly where the bladder will go. Then trace around the bladder. We need to mortise out the board with a router to recess the bladder into the bottom piece. I use a small trim router equipped with a hinge mortising bit. I use a jig that the router slides tightly in to make clean, straight cuts for the edges. You can easily build one with a thin piece of plywood or hardboard and a couple of fences equal to the width of your router base. I use the jig on each of the sides to get precise cuts. Once the perimeter is cut, I continue to clean out the interior material until it matches the bladder. Then route a deeper groove for the hose. A bit of chisel work to blend it all together and tune it until the bladder fits well. Turning attention now to the top piece. I cut a piece of hardwood the length equal to the width of the top and rip two 1.5 strips for the flip-up ends. Then rip two 1.5 inch strips for the sides the same length as the top. With all the pieces laid out, I cut the hinges in strips to fit the side pieces I just made. Because the thickness of the ball bearing casters are not tall enough to bring the base high enough, I add a strip of hardwood 3/16 of an inch thick to the 3/4 side pieces with regular carpenter's glue and clamps. The added thickness will ensure enough lift. After the glue has dried, I position the side pieces to accept the hinges. Although the screws are short, there are lots of them which will give it strength. Once the hinges are attached to the top, I flip it and lay out and install 5 bearings. With the sides complete, I now prep the flip-up ends. These pieces keep the casters in place when in mobility mode. I measure over 3 inches and mark for a through hole that will accept the clevis pin. Then back to the drill press to ensure nice straight holes. Attach the end pieces to the top with short pieces of the piano hinge, just like we did with the side pieces. We are ready for final assembly. The hinged top mates to the bottom with the bladder in place. Lining it up with the carriage bolts, we bring the two pieces together. Then short springs are installed over the carriage bolts and nuts threaded down until they reach the springs. To test the fixture, I loaded up the platform with what I had on hand. 30 pounds of weights, my 25-pound air compressor, and a couple gallons of paint. A few pumps of the bulb and the dead weight rises up. The ball bearing casters drop into place, then folding up the flip-up ends and slide the pins into the retaining holes. Deflate the bladder by pushing the release button on the bulb, and the weight sinks down with the bearings now supporting the platform base. It works amazing. It scoots around effortlessly in any direction. Once I move the platform where I want it, I again pump up the bladder and remove the retaining pins. Deflate the platform and it is stuck to the bench. Now that I know that the concept works, I once again disassemble it and put some paint on it to give it a finished look. After using it a while, I decided to add some small chains to keep the clevis pins from getting misplaced. I'm really pleased how well this worked out. It gives me the mobility I needed for the drill press, and at the same time maintaining the stability when it's time to use it. And it only added 1.5 inches to the already tall height. I hope you found this helpful, and it inspires you to build one for yourself. As always, I appreciate your time, and thanks for watching, and I hope you'll look me up again for the next fun project.